All right, this is quiz number 3 for Physics 101, 3T. Chapters, the second part of chapter 4, that includes inclined planes and friction, and chapters 5 and 6. Our first is a inclined plane. I have a mass of 2 kilograms. It's in an inclined plane as shown here. What must the force F be for the block to accelerate up the plane at an acceleration of 5 meters per second? 5 meters per second squared. Let's just draw the forces here. So I already have F, and then I have the force weight in that direction, and then I have the normal force. If I draw my axes, it looks like this, and this angle I know is 30 degrees. So I'm going to go ahead and draw my vectors. I have my normal force. I have FW cosine 30, FW sine 30, and F. And I want to know what must the force be for it to accelerate up the plane at 5 meters per second squared. So I know my acceleration is in that direction. All right, I'm going to look at the sum of the forces in the x direction. That's equal to FW cosine 30 minus F equals MA. Now, my acceleration has a magnitude of 5 meters per second squared, but be careful because it's in the negative direction. So I'm going to list it as negative. Now, I know the force weight. I'm going to take G equal to 10, and force weight equals M times G. The mass is 2 kilograms, so that gives me a weight of 20 newtons. It's cosine of 30 minus F, which is what I want to know, equals 2 kilograms times negative 5 meters per second squared. And then I solve that for F. Equals 20 cosine 30 plus 10, which is equal to 27, or listed as 30 newtons. So the answer is E. What is the normal force acting on the block in the previous problem? Oh, now we want to look at the sum of the forces in the y direction here. That's equal to 0. And I was just looking to find what is it, the equation. FW sine 30 is the normal force, not looking for a number. So that's going to be B. All right, what happens to the normal force on an object on an inclined plane as the angle theta is increased? This should say as, I'll fix it on the paper. So as you increase that angle, theta, remember my normal force equals FW sine 30. If theta goes up, this sine 30 term actually decreases. So if that angle decreases, the normal force decreases, B. When a car's tires are rolling, which of these is type of friction between the road and the tire? All right, that's static friction. If you think about this, your tire. This is the road. As this tire rolls around, the surface of the tire and the surface of the road do not move with relation to one another. It's only when the tires lock up that you skid across the road, and then that's kinetic friction if you skid. All right, a box of weight 100 newtons that was at rest on the floor where μs equals 0.5. Rope is attached to the box and pulled horizontally with Ft equals 30 newtons. Which way does the box move? Okay, well, it would seem that to the right would be the obvious choice, but that's not true, because if I calculate what is my static frictional force, my maximum static frictional force is equal to μs times the normal force. And in this case, my normal force is the same as the weight. The force weight is down. The normal force is equal but opposite to it. So that's 0.5 times 100 newtons, which is 50 newtons. So in order to make this move, I have to exert a force of 50 newtons or more. I'm only exerting 30 newtons, so it is not moving at all. Consider the block on this frictionless inclined plane. What is the block speed when it reaches the bottom? All right, well, this is a simple energy problem. I say up here, it has no kinetic energy, and its potential energy equals mgh. Know that it doesn't have kinetic energy, well, it doesn't say this, but I'll fix this, that it is at rest at the top of the inclined plane. What is the block speed when it reaches the bottom? Well, down here, the potential energy equals 0, and the kinetic energy equals 1/2 mv squared. So, I take the energy at the top and set it equal to the energy at the bottom, and I solve for v. My masses cancel. Root of 2gh, root of 2, h was 3, the square root of 60, which is 7.7 or 8 meters per second. So number 6 is A. Imagine that the inclined plane does have frictional force acting the block. If this force is 2 newtons, what energy is lost after the block is moved down the inclined plane? All right, well, the frictional force is doing work. Work is equal to force times displacement. It has a magnitude of 2 newtons, the force, and it's moving over a distance that is from here to here. So I want to find this distance. If you're clever, you can see that this is a special triangle, 3, 4, 5 triangle. Or you could use the Pythagorean theorem, 3 squared plus 4 squared, square root of that equals 5 meters. So the distance over which the force acts is 5 meters. So it's times 5 meters, which is 10 joules. Okay. If the frictional force is 2 newtons on the inclined plane, what kinetic energy does the block have at the bottom of the inclined plane? Well, it lost 10 joules, so I just need to find what is the total energy, and I'll subtract 10 joules from that. Let's just take the potential energy at the top, is m times g times h. See, the mass is 10 kilograms, h is 3 meters. 10 kilograms, 10 meters per second squared, 3 meters, 100, that's 300 joules, and then I subtract from that 10 joules, because that's the potential energy minus the work done by the frictional force is equal to the kinetic energy at the bottom. That's 290 joules. That's B. The box is being pulled across a rough floor at a constant speed. What can you say about the work done by friction? Friction does negative work. In this case, a box is being pulled in this direction with a certain force, but the frictional force is opposing that motion, does negative work. It actually takes away energy. How does the work required to stretch a string 6 centimeters compare with the work required to stretch it 2 centimeters? Well, potential energy of a spring is 1/2 kx squared, and this is equivalent to the work by the work energy theorem. If I stretch it twice as far, which is what, or excuse me, 3 times as far, 2 versus 6 centimeters, 3 times as far means I'm increasing this by 3, which increases this by 9. So D is the correct answer for number 10. Guy pulls a block 5 meters across the floor, as shown here. What work is done? Work is equal to F d cosine theta. F here is 30 newtons. D is 5 meters. And cosine at 60. That's going to be 150 times 0.5, which is 75 joules. So D is the correct answer. Okay, now for this problem, I also want to know what is the normal force on the block. I'm going to redraw this for just a moment. So I have my block. I have, actually I'm going to redraw it with my forces resolve. So I'm going to have F sine of 60 here and F cosine of 60 here. And then I have my force weight. I think that's the only forces I have, yes. Oh, and then also my normal force, which is what I want to know. So I say the sum of the forces in the y equals 0. Sum of the forces in the y will equal Fn plus F sine of 60 minus Fw equals 0. And so Fn equals Fw minus F sine 60. That is going to be the weight is 200 newtons minus the force, which is 30 sine of 60. That's 174, which is 170, rounds off to 170. So D is the appropriate answer. 1 kilogram block traveling to the right at 3 meters per second. It collides with a stationary 2 kilogram block, and the two blocks stick together. What is their final velocity? So here's my 1 kilogram block. Is traveling at 3 meters per second. And my 2 kilogram block, which is stationary. And then afterwards, the two stick together. I want to know what is the final velocity. I know the momentum of this system has to equal the momentum of this system. Up top, the momentum is just from the first block, so it's just the mass times the initial velocity, which is 1 kilogram times 3 meters per second. That has to equal the mass of the bottom, which is M1 plus M2 times V final. They're both going to have the same final velocity. That's 3 kilograms times VF. Solving for VF, I get 1 meter per second. That is A for number 13. Which of these statements is true? Well, is energy a scalar or vector? Is momentum a scalar or vector? Energy is a scalar and momentum is a vector. So that's the first one. Two boxes, one heavier than the other, are initially at rest on a horizontal frictionless surface. The same constant force acts on each one for exactly 1 second. Which box has more momentum after the force acts? All right, well, I know that F is equal to delta P over delta T. They have the same force acting on them for the same amount of time, so they both have the same momentum afterwards. All right, Alex throws a 0.15 kilogram rubber ball down on the floor. There's the ball speed just before impact and just after. What is the magnitude of the change in the ball's momentum? All right, so delta P equals M V final minus M V initial. That's going to be 0.15 kilograms. That's the mass. I'll factor that out, so it's going to be V final minus V initial. Afterwards, it's coming up at 3.5 meters per second. Initially, it was going down at 6.5 meters per second. So I have to make that negative. So that's 0.15 times 10, which is 1.5 kilogram meters per second. So that is C for number 16. And then same question, but I want to know what is the force. Well, force is, force is delta P over delta T. Just found, gosh, what was the change in momentum? 1.5 kilogram meters per second is the change in momentum. Divided by the time, which is 0.025. It gives me 60 newtons as the average force. 60 newtons for number 17, that's A. 75 kilogram diver dives horizontally off a 500 kilogram raft. Diver speed immediately after leaving the raft is 4 meters per second. What is the corresponding raft speed? So here's my raft, here's my person in the initial state. In the initial state, momentum equals 0. In the final state, the person goes off in this direction at 4 meters per second, and the raft goes off in this direction at some velocity that we want to know. So I say the initial momentum equals the final momentum, that's 0, equals the mass of the person at 75 kilograms times 4 meters per second, plus the momentum of the raft is 500 kilograms times v. And then we solve that for v. 75 times 4 divided by 500, which is 0.6, negative 0.6 meters per second. I was looking for the speed, so it's going to be c. In which of these collisions is momentum conserved? Okay, people colliding, yes. Gas particles colliding, yes. Cars colliding, yes. So it's D for number 19. And then finally, an elastic collision is one in which of these? In elastic, both energy and momentum are conserved. Remember, these are collisions that involve conservative forces like the gravitational force and the electric force, which are field forces. Since they're conservative, they conserve energy, and all collisions conserve momentum. All right, that's all.